Hello everyone. In this activity, we are going to do cyber attack on IEEE and the system segments in PSCAD. Before going to do the activity in PSCAD, important to know basic architecture of IEEE digital architecture. The total digital architecture is divided into three levels, that is station level, bay level, and process level. In station level, managing the entire substation is going to be happen, and coordination, operator interface with the different levels. At bay level, there are different IEDs such as circuit breakers, protection and control IEDs, isolators, switch gears, etc. are connected in bay level, and these all levels are going to communicate with each other in digital. And next level is process level. In process level, there are different merging units. MU means merging units, which is going to convert real-time data, unlock data from the substation to detailed data, and it is going to different levels. Because of this IEC 6150 architecture, there are numerous advantages in the power system protection, but such as faster the relaying response faster the fault clearance time, and also real-time monitoring of the power system is going to be. Similarly, with this architecture, we have some disadvantages and drawbacks. That is, the whole power system data is now going to convert into operating into the digital format. So once the data is converted from analog to digital format in the form of SPWare packets, there is a chance of cyber attacks. Here we can see that the detailed data is coming from merging unit, and it is going to the IED. IED will decide the operations, and it will give you the signals to control circuit breakers. Here, if the cyber attacker has access to the communication network or merging unit, then he can alter the data to the IET and he can perform cyber attack on the system. There are different kinds of cyber attacks. Majorly, we are going to do three kinds of cyber attacks in this activity. That is CTPT tab changing, false data injection, and replay attack. CTPT tab changing attack is nothing but the cyber attacker will alter the tab settings of in the merging unit level, so that voltage and current ratings from the meter is altered. Next one is false data injection. Here the attacker will inject some random type of data which creates the ID as a fault, and it will give a tip signal to the circuit breaker to open its contact. Next one is replay attack. In replay attack is nothing but the attacker has an access to the previous recorded fault, and the attacker replays those previously recorded fault data into the system, and it feeds to the AI. Now in this activity we are going to see three kinds of cyber attacks in PSCAD environment. This is our IEEE number system PSCAD. This is a normal operation of IEEE number system PSCAD. Here we are selecting maximum magnitude around 192 for the voltage, and 0.279 for the current. This is the maximum amplitude. This measurement we are going to do false data injection. So further thing, first here you can see I already written the code. Voltage magnitude Vm is considered 192 and current is considered 0.297. With this thing here we generated actual measurement. These are the voltage signals from 0 to 2 seconds. These are the current. Now with that generated input signal, we are going to do some false data injection, random data into the system. This line is to export false data in the CSV format. These are some random data generated here. This is for voltage and this is for current. Now we are storing this data into the same file location. This is my IEEE number system file and I am saving this generated false data into the same file location. FDIV for false data injection voltage signal and false data injection current signal. Relative path for of the columns. Three-phase currents and the three-phase voltages we are including. FDI is three-phase voltage and first column is for time. So total 4 columns. Now this is the voltage signals we generated from the step random data from starting 1 second to 0.5 seconds. Similarly, three-phase current data is generated random current. Now we are going to use the signals to alter the measurement from the actual IEEE numbers. Now I am doing fast data injection for only AFS. This is our actual system measurement. But if the attacker do fast data injection, the relay will see these kinds of waveforms as an input. Here we can see this is the different what is going to happen with cyber attack. Really, if you see the voltage waveforms, voltage waveform looks like this. If the cyber attacker do some operation in the and it will alter the waveforms input signal to the IEDs, then the IED or relay will see these kinds of waveforms as an input, like these kinds of altered voltages and this type of currents. So this voltage and current signal will give trip signal to the circuit breaker. The relay will see it is an actual fault in the system. Similarly, now we can do CTPT attack, cyber attack on CTPT. So now, if I wanted to disable this thing, simply I can select and disable this like without deleting the system. But CTPT attack, Now here also we are going to do cyber attack at 1 second. What I am trying to do here is I am trying to increase the current by multiplying 10 and reduce the voltage by 0.1. Like current will increase during the fault and voltage will reduce. So I am trying to do those kind of CTPT attacks. This is the current waveform. Here we can see that current value is significantly increased. At 1 second voltage is reduced. If you see actual measurement, there is no change in the actual physical system practically. There is a no fault, nothing. But due to this kind of CTPT cyber attacks in the real-time network, the relay will think it has a fault and it may produce a trip signal to the circuit breaker. No other kind of cyber attack is ripple attack. In this scenario, the attacker records the actual fault in the system. Let's say we are creating a fault, AG fault 50%. Here, like fault duration is 0. Here, this is a voltage waveform. This is the current waveform during the fault. Actual fault in the system. Now, cyber attacker has the access to record this kind of actual fault and he will use same waveforms to produce cyber attack. So for the copy, I have pasted the whole C7, save this file. and I saved this file in same location where I am having actual PSCAD file and MATLAB file. Here we are loading the data, whatever the saved, and again we are exporting into the .csv format. So these are the voltage current waveform, and the voltage time, and it is exported into the same file location. Here you can here the replay file. Now that is again we need so one is time, two are the waveform. This is the current replay attack current. This is the actual power system current. In fact, actually there is no fault and no change in the system. But due to the replay attack, the attacker will provide this information to the relay, and the waveform of the voltage and current relay will see like this, and it will produce an PEP signal. This is three kinds of cyber attacks in IEEE and the system. Thank you.